Hello, this is Mrs. Ward, and this is a video going over section 10.6, parametric equations. So the best way for me to explain what a parametric equation is it's the introduction of a third variable. So I think of kicking a soccer ball. When I think of kicking a soccer ball, there's three things that are going on with a soccer ball. One is it's going to have a horizontal distance. The other variable is going to be its vertical distance. And the third variable, the introduction of this third variable, is going to be how long the ball is in the air, which is going to be the time that the ball is in the air. So we're going to relate the height to the time that the ball is in the air. We're going to relate the horizontal distance to the time that the ball is in the air. And then we're going to put all three of those together and put it back into a rectangular equation. So we're going to have a parametric equation and a rectangular equation. So the first thing we're going to learn how to do is evaluate sets of parametric equations giving values for the perimeter. Then we're going to sketch the curves that are represented by a set of parametric equations. Parametric equations have to come in at least a set of two because that's how you introduce that third variable. And then we're going to rewrite sets of parametric equations as a single rectangular equation by doing what's called eliminating the parameter. And then we're going to find sets of parametric equations for graphs. So first thing I'm going to do is I'm going to tell you that the parameter is going to be the third variable, and most of the time we're going to call it t. The parametric equation is rewriting both x and y as a function of t. So if I have a curve, I'm going to say x is equal to f of t and y is equal to g of t. So the function for f of t and the function for g of t are not, they're very rarely the same. So here we go. Let's just do one. So if I want you to sketch the curve and I tell you x is equal to t and y is equal to negative 2t, and I define the parameter of t between negative 2 and 2, the first thing I'm going to do is make a chart, and I'm going to put the values for t in, which we'll just do 0 through 2. X I said is equal to t, so I'm just going to put t in here, so that's going to be negative 2, negative 1, 0, 1, and 2. That was simple. And then y is going to be negative 2t. So negative 2t. So I'm going back here to the t column and multiplying by negative 2. And when I do that, 2 and 4. Now when I go to graph this is graphing a typical xy pattern. So I'm going to do negative 2, 4. And it's important that I remember the order that I'm going in. Negative 1, 2. 0, 0, 1, negative 2, and 2, negative 4. So I have this, oops, got to know where negative 4 is. I have this graph that goes like this. Now I'm going to do the direction because a parametric equation has a direction, and the direction is going to go down. And the reason why it goes down is because if I go from left to right for my t, then the order that I went for is negative 2, 4, negative 1, 2, and that's the order that I went in, so my graph is going downward. So when I'm eliminating the parameter, I'm going to solve one equation for t, and then I'm going to substitute that t into the other equation so that I'm left with both x and y. So let's just do one. So it says sketch a curve represented by the equations of x is equal to 1 over the square root of t and y is equal to 2t squared by eliminating the parameter and adjusting the domain of the resulting rectangular equation. So I'm going to solve one of these for t. So let's suppose I solve x for t. And if I do that, I'm going to have x the square root of t is equal to 1. The square root of t is equal to 1 over x. And then I am going to square both sides. And I'm going to get t is equal to 1 over x squared. Then in place of this t here, I'm going to write what it's equal to. So this will be 1 over x squared. And y is equal to 2 times that. So y will equal 2 times 1 over x to the fourth. So y is equal to 2 over x to the fourth. So there's my x, and here's my equation, the rectangular equation. Y is equal to 2 over x to the fourth. So when I go to adjust the domain, I'm going to have to go back up to my original equations here, and here I see the t has to be greater than 0, not greater than or equal to 0, but greater than 0, so that the x is not undefined. So if you were to graph this on your calculator, this just the way it is, you would get a function that looks like this. But since I'm saying t has to be greater than or equal or greater than 0, that eliminates this side, and it's just going to be this graph here. So that's the rectangular equation. If I wanted to know the direction, I would probably make an txy chart real quick. So t, x, y, and I'm probably going to do 1, and 1 over square root of 1 would be 1, and then this would be 2. And the next one I'm probably going to do is, let's do 4, because that's an easy square root. So that would be 1/2, and then if I put in 4, that would be 1632. So if I look at this, the first pair I would draw would be 1, 1, and then I would draw 1/2 32. So the direction is going to be towards the left. And that's how I would find the direction. I would probably just go ahead and graph that part on the calculator though. Looking at the, start with 0. I know it's greater than 0, but I'm just going to start with 0 to give me an idea of where I'm starting. And then I'm going to do pi over 2, pi, and 3 pi over 2, and then I can finish with 2 pi. So if I do this, the cosine of 0, so this one would be 2 cosine theta. So the cosine of 0 is 1, so this will be 2. This one is 2 sine theta. The sine of 0 is 0, so 2 times 0 would be 0. When you go to do pi over 2, the cosine of pi over 2 is 0, so this whole thing is 0. The sine of pi over 2 is 1, so this would be 2. That's pi. This would be negative 1, so this will be negative 2. This will be 0. 3 pi over 2, this is really messy, and I'm really sorry, will be 0. And then sine of 3 pi over 2 is negative 1, so this is negative 2. And then 2 pi and 0 are the same points, so that's going to be back to 2, 0. So when I sketch this, and I'm just going to do a rough sketch, 1, 2, 1, 2, 1, 2, 1, 2, I'm graphing 2, 0, 0, 2, negative 2, 0, 0, negative 2, and then be back here. So I'm going to make this circle. And notice the way that I drew it is going to be counterclockwise. So that's the first part. I sketched the graph. Now, it told me to do it by eliminating the parameter. I'm going to do that next. I am going to go back and remember that cosine squared theta plus sine squared theta is equal to 1. And that's what I'm going to use to eliminate any parameter that has sine and cosine in it. So in order to do this, I need to rewrite cosine something is equal to cosine. So right now I have x is equal to 2 cosine theta. So divide both sides by 2. So x over 2 is equal to the cosine of theta. And then y is equal to 2 sine theta. So divide both sides by 2. Y over 2 is equal to sine of theta. So to eliminate the parameter, I'm going to say cosine squared theta. Well, cosine theta is equal to this. So I'm going to say x over 2 squared plus y, which is this, is equal to 1. So I am going to have x squared over 4 plus y squared over 4 is equal to 1. So I have two variables that are squared. I'm adding. I have the same number down here that tells me when I'm adding, I know it's some type of ellipse, but since those numbers are the same, I know it's a circle. Usually for circles, we multiplied and just had x squared plus y squared is equal to 4. So this would be a circle with the center at 0, 0 and a radius of 2. And that's exactly what I drew up there. The only difference is between this rectangular equation that I have here and when I graphed it in a parametric is the parametric helps me get the direction of that circle, because with the parametric equation I need the direction. Okay, example number 4. You are Find a set of parametric equations to represent the graph of y is equal to 4x minus 3 using the following parameters. So the first one, A, they tell me t is equal to x. So my first equation for the parametric equation is going to be x is equal to t. All that kind of makes sense. Then the next thing is in place of this x, I'm going to write t. So I'm going to say y is equal to 4t minus 3. And that's my parametric equation. That wasn't too bad. For part B, I'm going to say I'm going to add x to both sides, subtract t from both sides. So I'm going to say x is equal to 2 minus t. Then to find my y, I'm going to say y is equal to 4. In place of this x, I'm going to write 2 minus t minus 3. And then I'm going to simplify. So I'm going to say y is equal to 5 minus 4t. So that's my pair of parametric equations, or those two there. Okay, and the last thing is using your calculator. So you are able to graph your calculator. This is actually number 94 in your book. You are able to graph in a parametric equation. So for the last couple problems, they're asking you to use the, for the projection motion, they're trying to show you that this gives me my horizontal distance of an object. This gives me my vertical or my height of an object. In this case, the t stands for time or how long that object is in the air. V sub 0 is the initial velocity or speed, and h, this h here, is the initial height. So I'm going to first graph it in parametric equation because I want you to know how to graph it on your calculator parametric equation. And then we're going to have to adjust it to answer some of these questions. So it says an archer releases an arrow from a bow at 5 feet above the ground. The arrow leaves the bow at an angle of 15 degrees with a horizontal and at an initial speed of 225 feet per second. And that's important because my velocity needs to be in feet per second. Write a set of parametric equations that models the path of the arrow. So the first one is going to be my horizontal distance, so my x is going to equal my initial velocity, which we just said was 225 feet per second, times the cosine of my angle, which in this case was 15 degrees. I'm going to put that in parentheses. And then I'm going to multiply that by my t, which is time. And then this x, so that gives me my horizontal distance. My vertical distance, or the height, is going to be the initial height, which they tell me is 5 feet, plus the 225 times the sine of 15 degrees. That's the sine, initial velocity times the sine, times t minus 16t squared. So assuming the ground is level, find the distance the arrow travels before hitting the ground, ignoring air resistance. Use a graphing utility to graph the path of the arrow and approximate its maximum height to find the total time that the arrow is in the air. So when I did this one, I first graphed it in a parametric equation function on my calculator, which I believe you guys have never done before. So let's go to our calculator and see how we do that. So I'm pulling up my calculator. I am going to open a new document. So let me see if I've opened a new document. I'm going to put it in a document because I want to add a couple pages to this. The first thing I'm going to do is I am going to add a graphs page. Right now it's in function. I don't want function, so I'm going to entry edit, and you will see number 4 is parametric. That's the one I'm going to choose right now. So remember, I came up with 2 parametric equations. I came up with this equation here for x and this equation here for y. See how this is actually x of t and this is y of t. So when I go to type this in, my x is going to be that 225 times the cosine of 15 degrees. I'm putting in a degree symbol because my calculator is set in radians. Going outside the parentheses, I'm going to then multiply it by t. That's the biggest mistake, is forgetting that t. Because this is like f of x, or in this case x1 of t. You need to have that variable t in here somewhere. Y1 is going to be that 5 plus, and then I think it was 225 times the sine of 15 degrees. And then this is times t. And then I have minus 16 t squared. Then I'm going to look at the rest of this. See how it says 0, t is between 0 and 6.28? Well, that should look familiar. That's set up for to be in radians, because normally one lap around the unit circle would be 2 pi. 2 pi is 6.28 units or radians. So since I am in radians, that's great, but here I put these in degrees. So I'm going to change this to 360 because I am doing 360 degrees, and it's reading those inputs as degrees. I'm going to hit enter, and I'm not going to see much. And then I'm going to ask myself, well, does this window really make sense? And it doesn't, because I'm not going to have a negative horizontal distance. I'm not going to have a negative vertical distance. So I'm going to clean up this window a little bit. I like to pick my window settings to see how I do. I'm going to do -10. That's fine. I'm going to guesstimate that the most this object, this arrow go in the air is, let's say, 200 feet. I don't know if that's right or not. And let's say I say that's, oh, I'm sorry, that's a horizontal. I'm just going to say maybe it's going to go 200 feet, and let's say I'm just going to do a height of 200. I know those are wrong, but there I go. So I have this. I can see the start of I should expect a parabola. I can see the start of my parabola. So I'm going to, my height is fine, right? My height is fine. It doesn't look like the arrow is going to go much higher, but my vertical distance is way out of whack. I don't even seem to see the down pass. So I need to know that I need to go twice as large as I've done. So let's go to window settings. I said at least, let's say I say 500. Hit OK. I start to see the top of my parabola shape, but still don't see the end. So I'm going to do that again. Again, it's not hurting you to think about this for a little, but let's double that and see what happens then. Let's go up to 1,000. Okay, 1,000, perfect. I see this nice parabola shape, which is what I was expecting. Because any path of an arrow is going to be a parabola shape. So here I have this, and I can see what's going on. Here's my problem. When I go to analyze graph, and let's say I say 0, because it wants to know how long the arrow's in the air, and the arrow's in the air until it hits the ground again. See how it says graph? It's looking for a function. I don't have a function here. I have a parametric equation. It's not going to be able to read this. Let's see if I can do anything else. Trace. Can I trace the graph? So it does have that little spider guy, so I can move that little spider guy around, but notice how he jumps, like he's really not helpful. Like my maximum height looks like it's going to be about 57, but it might be higher. I don't know, but it jumps from 0 to 57, and then here it's at -18.6, which again is not realistic, which tells me that I'm not going to go more than 869 feet, because then I'm underneath the ground, and that doesn't make sense. So in a way, this lets me see the shape, but unfortunately, it does not let me answer some of these questions that I want to answer. So I'm going to go back to the page, and I am going to eliminate the parameter. Now, I know it doesn't say to eliminate the parameter, but if I want to answer these questions, I have two choices. One, I can either solve it, or I can eliminate the parameter and come up with a function to have my calculator do it for me. I'm going to choose the latter and have my calculator do it for me. So what I'm going to do is I am going to eliminate the parameter by solving for t in one of the equations. The easiest equation to solve for t is going to be the x equation. So I am going to look at this x equation. I'm going to solve for t. When I do that, I'm going to say x over 225 cosine 15 degrees is going to equal t. That was simple. And I can actually even find this decimal if I wanted to, because this is going to be a decimal of some sort. I don't know what it is. I didn't bother finding it. I am going to take this, and every place I see that, I am going to stick it in for t. Now, I could do this the hard way or the easy way. Let's do the hard way. Why not? So I am going to put x over 225 cosine t any place that I saw a t here. So the function that I'm going to want to write, I guess I should write it for you, is I'm going to do y is equal to, so this is what I'm going to type into my calculator. Whoopsie. Oh, won't get out of my way. I'm going to do y is equal to 5 plus 225 sine 15 degrees times x over 225 cosine 15 degrees minus 16 times x over 225 cosine 15 degrees. So I opened my same calculator page that I had before, and I am going to hit tab, and it's going to be in parametric, but I'm changing what I want to do, and I want to graph something in a function. I'm going to leave this parametric equation here because I want to make sure that I did my substitution incorrectly. So when I do this, this graph should be right on top. So I'm going to hit menu and then go to graph entry edit, and I'm going to do function. So it's going to let me graph on the same page and see everything on the same page, but it's not going to let the parametric equation interact with the function equation, if that makes sense. So I'm typing in that equation that I just wrote there. So I'm going to have 5 plus, and then I'm going to do 225 times the sine of 15 degrees. And then this is times, and then I'm going to put this in parentheses and hit control divide. And then what I just said t was equal to, which is x over 225 times the cosine of 15 degrees. Now you could have simplified this along the right way, and you could have, like on this one, the 225s could have simplified, but I chose not to do that. So then I'm just going to leave it the same. So that's t, and then I'm going to have minus. So I'm going to get out of that whole thing, and I'm going to do minus 16 and then t squared. So again, I'm going to hit times, put in a parenthesis again. And I know this seems long and difficult, but as long as you're careful, and I hope I'm being careful, but I'll know instantly if I made a mistake because the graphs won't match, and the graphs should match. If I eliminated the parameter correctly, the graph should be exactly the same. So O squared, squared, squared. Okay, hit enter. And bazinga, I have the function landed right on top of the parametric equation. So this parametric equation is the same as this rectangular equation, which is long and ugly, but there it is. But now I can answer the rest of the questions. So one question was, assuming the ground is level, find the distance the arrow travels before it hits the ground. So it wants to know when it's hitting the ground. So I'm going back to my graph. I'm going to do menu, analyze, and I want to find the zero because that's the zero height is when it's going to hit the ground. Again, this is saying lower bound, upper bound. So here at 809.3 feet, it's going to hit the ground again. The next question it asks me is use a graphing utility to graph the path of the arrow and approximate its maximum height. So now it wants the maximum height. So I'm going to do menu, analyze maximum and lower bounds, upper bounds. And so right here, the maximum height, remember, is the y value. It's going to be 57.99 or approximately 58 feet. That occurs when the arrow is 395.5 feet away from where it started. The horizontal distance would be that 395.5. The maximum height is at 57.99. And the last thing is find the total time the arrow is in the air. There I've got to do some math. So to do some math, what I'm going to do is I'm going to bring these over. We said, why can I? We said right here that this is when it hits 0. So I'm going to copy this over and bring it. So the last question is asking what the total time was that the air was in the air. Well, there's two ways I can solve it because I have two equations. I have this x equation. X is equal to 225 times the cosine of 15 times t, and then I had the y equation 5 plus that whole thing. So when the arrow, the last time the arrow is in the air is at this point here, this 809.30. So there's two ways that I can solve this to find the maximum time that this arrow is in the air. And one would be to take the 809, which is the x value, and set that equal to the, put that in here for this x right here. So one equation I can do is 809.3 is equal to 225 times the cosine 15 degrees times t. And then to find t, I'm just going to take that 809 and divide it by 225 times the cosine of 15 degrees. And that would just give me my t. By far the easiest way. And I'm going to get an answer, and I'll show you that answer in a second. The more difficult way, but still totally doable, is when I want my height to be 0. So I want this y to be 0. So I could do 0 is equal to, and I'm going to put in descending order of exponents because that's the way my brain works, negative 16t squared plus 225 times the sine of 15 degrees t plus 5. And obviously, this is not going to be factorable, obviously, but I can do the quadratic formula. I'm going to find a decimal for this and do it. So I'm going to show you on my calculator both ways. Now, you only have to do it once, but if I do it both ways, if I'm having a good day, and I already did it, so I know I'm having a good day, you should get the same answer. So that by far the easiest way to do it, let's get out our calculators. And I am going to add a calculator page. And the easiest way is to take that 809.3 and divide it by, oh, I should have used my favorite button. I didn't. So since I did not use my favorite button, I am going to have to do a parenthesis. Should have thought of that. 225 times the cosine. Because remember, the cosine of 15 degrees is some decimal. I don't know what it is. I don't really care what it is. I just know it's a number. And if I hit enter, it makes it a fraction the way I want it to be a fraction. The 225 is times the cosine of 15 degrees in the denominator. This is 3.72. So the answer to the question is that the arrow is in the air for 3.72 seconds. But let's do the other way. The other way, I have to do the quadratic formula. Oh my goodness, have to do the quadratic formula. But before I do that, let's do myself a favor. 225 times the sine of 15 degrees, and that's going to be a decimal of 58.23. I'm going to use that whole decimal, but when I write this, I'm just going to write 58.23. So to find this, this is 58.23, and I hate it when my pen does that. So now I'm going to do the opposite of B, which is at 58.23. Plus or minus the square root of that 58.23 squared minus 4. A is negative 16, 4ac 5, all over 2a. 2 times negative 16. So remember on my calculator, I'm going to separate it into two, one with a plus, one with a minus. It should make sense to you, coming back to the board, that when I have this Here I start at 5 feet and the arrow goes like this. There is going to be an answer that's over here that's negative that I'm going to roll out, and I'm only going to take this positive one. Just a visual of what I'm doing. So here I go using my wonderful calculator. I already have this, so I'm going to make a fraction. I'm going to do the opposite, and I'm going to go up and grab that because that's the opposite of b. I'm going to do plus first, plus the square root of b. So let's go up and grab b again. B squared minus 4 times negative 16 times, which is a, times c, which is 5. And this is all over 2 times a, which is negative 16. When I do that, I get a negative answer. Well, that's the one before the arrow went off, so that's not the one I want. So no problem. Go up and grab this. Just sort of slide over here and make this plus sign a minus sign. And look at that. I get 3.72. And that makes me so happy because that matches the 3.72 that I have up here. So you could do either one. I just wanted to show you that both of them work. So the answer to the last question is that arrow is in the air for 3.72 seconds. All right, those are the notes. We don't worry about the homework. We'll talk a little bit more in class. And